Hi, welcome to the Data Playbook podcast. It's a podcast where we aim to build a playbook for data leaders. We do that through a series of interviews with other data leaders, data practitioners, and data experts. The topic of the first episode is building data architectures from scratch. With the turmoil in the US going on these days, more and more companies are wondering how much reliance they should have on US cloud services. So in this episode, we look at what are the data architectures that are available, and do you even have alternatives? Are there options for you? Because what if the trade wars in the US escalate? Or what if certain services are cut off or made more difficult to use? What are the options that we have as European companies? I am Kris Peeters. I'm the founder and CEO of Dataminded. Dataminded is a data agency from the EU. We are based in Belgium, with also an office in Germany. And today I have with me our very first guest. His name is Torsten. Torsten, welcome to the show.
Thank you.
To begin, can you quickly introduce yourself?
Yeah, thanks, Kris. Hi, I'm Thorsten Foltz. I'm actually working for Dataminded since a couple of months, but I have experience working as a data engineer, data architect now for many, many years in also another consultancy and a startup. So, and that's what I'm actually doing. My background itself, so I have a master degree in economics actually. And yeah, how did I came to data engineering? Actually, happens randomly because at one day I started as an analyst.
Yeah.
And then there was the task of, hey, actually, we need some data warehouse because what they had at that time wasn't sufficient. And it was just a question, hey, we know you can program. Do you think you can do that? And you know me, I'm just saying, yeah, why not? How hard can it be? And I tried it out. And turns out I like actually data engineering far more than data science, data analytics or so. I'm really a guy enjoying that one. And now building actually end-to-end pipelines, drawing architectures. That's what I'm doing. And I like it.
So you're not on a quest to save the world, you're on a quest to build better data systems. Is that correct?
Yeah, better data systems. I mean, if you would ask me, what can we do? And I mean, let us be honest, we have huge technology possibilities nowadays. I mean, we will later talk maybe a little bit about AI. And when you think about what could I do, and that is actually perhaps a good starting point, especially to the United States, if I could prevent anything using data, it would be preventing fake news. Because that is what you see many times. You open the internet and things are just wrong. And it's getting more and more harder to distinguish what is even right and what is wrong.
That is true. And that's also true within companies, right? So it's quite easy to throw a bunch of data together and build a report. But that report might as well just be fake news as well, right? So can you tell me a bit about that? How do you look at, let's say, bringing all the data together in a company and trying to build insights from it? If you want to prevent fake news in a company, how do you do that?
That's a good question. I mean, let us be honest. No company is equal to another. There are always differences. And what we see, especially many companies are more maturity and they are existing. I mean, if you look at the German market, many companies exist here for decades.
Yeah.
And they have a lot of data. But just over history, I mean, just look back in the past, storage was expensive. You store it on different systems. And nowadays, still, you have a lot of silos. You have data everywhere. I would even say many companies don't even have an overview what data they even have or what they can do with data, because even the smallest data sets can have a value. It's just a question.
Yeah. So for you, it's not a matter of having more hardware or more compute or having bigger data sets. It's about bringing the right data together. Does that make sense?
Bringing the right data, or make an exploration. What data do I have? Bringing it together. And then, I mean, storage today is, if you compare it, very cheap. So meaning you can store the data, we have the possibilities, especially when we talk about cloud systems. And then think about, okay, what data do I have and what can I do with that? And not only, I mean, many people still nowadays think it takes the data to make a report and then make a decision based on that report. And that is, of course, the default stuff.
Yeah.
But there is more inside of it. You can make models, you can make predictions. You can really, it as a CEO, you should make, and that's what I really believe, you should make decisions based on data and not on gut feelings.
Yeah.
So.
Yeah, absolutely. And I also strongly believe that in that journey, most companies are at, let's say, 10% of what they can do with data. And 90% of the data potential is still untapped in companies. I'm not sure if they all realize that. But maybe let's start at the lowest level, at the infrastructure level. So if I want to do more with data, there's a whole discussion about, should I go to cloud? Should I do on-prem? Should I build hybrid systems? How do I make, as a company, how do I make a decision between those infrastructure options? And what are those options to begin with?
You mentioned it. Actually, you have, when we make the classical and don't want to divide it too much, you have actually on-prem, what you know. So you have really your own servers in your basement or wherever. You have the cloud environments. And of course, you can make a combination out of it. The answer is typical for a consultant. It depends. But it's really the truth. The problem is just think about what data do you have and what do you want to do with your data? Because I like the cloud and I'm really a friend of the cloud, and it has a lot of advantages. However, if you say I have data which must be really, really protected because it's very, very sensitive.
Yeah.
Then I would be even careful. Should I even store it anywhere where I can access it with a network via the internet? I'm not sure. On the other side, also think about when it comes to security. That's what I often hear. Now I want to store it on-prem because the cloud, I don't know where the data is. However, think also about, do you have, let's call a guy Peter, who is your IT admin for 30 years, and he's the only one. Does he have really the same knowledge as a complete security IT team, for example, at Google? I have my doubts.
Yeah, probably not. Yeah, no, that's true. At the same time, I do agree with you that the security teams at Amazon and Google and Microsoft probably build more secure systems than you can do. But it doesn't mean there is a fallacy that some companies say, hey, we go to the cloud because then it is secure, because then we have the security of Amazon. But there is this concept called a shared responsibility principle. What is it? Can you explain it to the viewers? What does it mean to have shared responsibility in the cloud?
I would say, just let us start maybe more from scratch. Should I go for the cloud? And you say, I just want to go to the cloud because everyone does. That's the wrong way of thinking from my point of view. What you should think, okay, what are advantages if I compare the cloud to my on-prem system? So first of all, they say often, it's cheaper. At the beginning, it's true, because if you just start an EC2 instance, for example, at AWS, it costs you just a few dollars.
Yeah.
If you compare it to the cost, if you buy a local computer, a complete server, which can easily cost 10,000, 15,000 euros and more. So that's the first point. But then ask yourself, what do I do with that? So for me, for example, the cloud is great for having a lot of storage, or especially scalability. That's great. Nevertheless, when you come about shared responsibilities, never forget the cloud is a tool. Just a tool. Meaning, if you say, for example, I store my data in some S3 bucket, Azure Blob Storage, whatever, and you open that storage publicly for the internet, it's your fault. It's not the fault of Microsoft or Amazon.
Yeah, and it has happened this big news headlines, S3 has been hacked. It wasn't hacked. You just made your data publicly available through S3. It's like, that's like if I leave the door of my store open all night long and people come in and steal from my store. It's like, oh, my store has been hacked. No, you left the door open.
And you touched a very good point. Just think about if you're leaving a little bit your bubble of IT guys, and just think a little bit in your private area, what people you have who are non-technical people. I have heard it often, I got hacked by somebody. To be honest, and I would say all cases I know, you are not just hacked because somebody wanted to hack you. It was just because you use simple passwords. You don't use a second factor. You use your password everywhere. You don't update your systems. And that's actually a point where I often say to all the guys, update your systems, because there are all the security problems which have been detected. They are published after some time. And meaning, if you then don't update your system, you make it people even easier to get into your system. So, and that's from my point of view, if you really get hacked by somebody and you follow all these advices, then it was really professional and not just some default guys.
Exactly. And then if we go one layer up the stack, so we go a bit away, we have chosen our infrastructure, then we need to decide on how to store the data. So for decades, we've already had data warehouses. Now lakehouse architectures are a hot new thing, and even newer are data mesh architectures. So if I run a data organization of a company, I hear all these buzzwords, and let's be honest, they are buzzwords for the most part. How do I decide between, do I need a traditional data warehouse? Do I need a lake house? Do I need a big data system maybe even? Do I need a data mesh architecture? How do I make that decision?
That's also, I would start actually, look at your company. What do you do? What do you expect from your data? So meaning, how big is your data already? And especially, what do you expect the growth? Does it grow in the same way, or does it grow maybe 10 times, 100 times, 1,000 times? Think about that. And then, I mean, you mentioned the traditional data warehouse. You can use actually every database for that. It's a monolithic system, and it's fine to use it nowadays. If your data is not that big, if you're rather a small company, fine for that. The moment you work with bigger data, you get more insight. And let us be honest, nowadays, if you just have a website, you track so many data, every company does that, then you need to store it. And then it makes sense to store the data in a data lake, in a data lakehouse, and use it from there. Then we have the next step, and that is what we see actually quite recently in the last couple of years, I would say. You have the problem that you have a centralized data team, and there's not really wrong to have something like that. The problem is often they are the bottleneck. They are overwhelmed by too many requests, and even if you solve that issue of having a team which can react flexible and quick, you have often another problem. You have data engineers. It's even true for myself. When I go to a client, I know how to work with data, and I know how to store, how to provide, and so on. But what is in the data, what makes the value out of it, I have no clue. And the central data team often is the same, meaning you need business people. You need people who understand, who can do something with that data. And that is where the data mesh come in. That we say, let's think about maybe not put everything in a centralized team. What if we go the data engineering more into the business domains, let's say, that you say, hey, you have an engineer or maybe two in a certain team. There is some common frameworks that you say, okay, we have some certain rules for data governance, for providing data, but you have your own data guys there who provides data in a good way. Because if you do that, then at least you get the bottleneck a little bit out. It comes also with more complexity. Let us be honest. You need the guys who can do that. If you have, and that's often a problem, if you have a culture where people just say, yeah, we want to work with data, but we don't want to provide or even maintain it, which is actually more harder than just providing, then you have another problem that you need to think about. So it's always, I would say, as a common factor, don't just overthink the technology side, because there are many technologies outside and there are consultants who can help you, but also always think about what people do you have and what people can you get, because without the people, it will be hard.
I think it's one of the hardest problems in data today, is that what you just described. On the one side, you have central data warehouse teams that have all the technical expertise. Indeed, we engineers, we can build all the data pipelines you want, and they can be as complex as you want, and there can be some machine learning in the pipelines that can scale to terabytes of data. That's our world, right? That's what we know. That's what we do best. But indeed, for some businesses, it's very hard to believe, but we don't understand the data. And even if we do, like, so sometimes you see data warehouse teams that have been there with the same company for a decade or more, and they start. I mean, they understand the data that they're working with, but even for them, you cannot expect a single team to understand all the different domains in your company. If you're a sufficiently large organization, there is no single team that can be the team that understands your data. It's this concept that has been, people have been believing this for 2 decades that can be true, but that's just a lie, right? So what happens is that companies let data warehouse teams build entire data pipelines, and then some reports come out of it, and then after like 2 years of building that, the business says like, oh, all this data is wrong, and they blame the data warehouse team. But I strongly believe, even in small organizations, that the ownership of those pipelines should be with the domains. I'm not saying everybody should build out full data meshes and you should have an engineer in HR and an engineer in marketing and an engineer everywhere. But conceptually, the ownership of what you built should be with the domains.
Yes.
Do you agree with that?
I agree totally with that, because even when we just take a very simple example, it's not even, we talk about, okay, so we don't understand the data. And then you can maybe say, why do you don't understand the data? For example, we just show a turnover. And yeah, of course, I know that's the turnover of the company. Now, the problem is, I don't know, how is this turnover defined? So maybe there are some filters before which has been set or which must be there. I don't know that. And in addition, going to a company and then, I have 10 million euros turnover, for example. Is that now a good one or not a bad one? Exactly. I have no clue. Because I don't have the business. That's what I meant. We are technical guys. We can do the technique, but there's always a business side, and we should never. Sometimes it is unfortunately the case where we have also to do some people management, where we just say, hey, it's not that we have on the one side the technical guys and on the other side the business side, and we are enemies. No, we work as a team, and you need us for all the technical things that you can even work with the data, but we need you. We need you to explain us, what do you want to achieve? Which data do you need? How should we model your data? How should we, even when it comes then later to the analyst, how should we provide data? So meaning you must work together.
And it's crazy that we all know this when we talk to each other about it. It's like in conversations like this, we all know that we need to work closely with business. Yet in practice, I meet so many companies where from both sides, there is still a very large divide between business and IT, where business says, well, we just do things ourselves in a couple of days, because if we ask something from IT or from data, it takes 200 man days to do something, so we cannot wait for that. And at the same time, when you talk to central data warehouse teams, they can talk all day long about ingestion patterns and CDC and type 2 changing dimensions. But they sometimes literally say like, no, I don't talk to business. That's not what I do. So even though we all know this in our hearts that we should work closer together, it's still very, very hard to do so, right?
Yeah, I think, never forget, everyone is different. So, and some people just like it to sit in the corner alone, do programming all the day, and they are great at that, but they don't like to speak to people. Whereas you have other guys, if they cannot talk to anyone for an hour, they get frustrated. So we are just different, and that's what I meant. And for me, it's also the case that I said, look at what is your strengths and what is not so good. And if you, for example, if you say, okay, I have a great IT team, but nobody is really willing to talk, to communicate, then I must fix that problem by introducing a good project manager who takes care about that, by introducing a scrum master, whoever position you want to name, but by somebody who can then take over. And that, again, we are talking about the team. And I think that's also a very big changement. All the people look at the media. If you say, oh, we have some hacker, what do they show? Always the same guy who's sitting in the dark.
With a hoodie.
Exactly, with a hoodie in the basement. He barely can see something because it's dark. And he's just doing some coding. And that is what many people still imagine. You have a guy, an IT guy who's just doing some coding alone. That's not the truth. We work as a team, because you will, at least you should never have anybody today who's just coding alone. At least you have a second guy who's doing some review about your code. before you go for production and all these things. So working as a team is quite important. And that means also you have different strengths in it. Like you have the one guy who is an expert in databases, you have another who is an expert in infrastructure, so that you bring them together and we just think the way afterwards. So meaning then you need also somebody who can just talk to the business. So meaning act as a translator. So understand the business side and understand the technical side and also understand their needs and requirements. That's often what you have the same experience that, like you mentioned, hey, I just want some data. It's actually should be done in a day. If we just should provide you that data, it is probably done in a day, but you don't want the data one time. You want it actually every day in a good quality. And that means we must make sure the data is incoming every day. It is treated correctly. We have a monitoring, we have warnings, and all these things which comes afterwards. And that simply takes time. But that's also my experience. If you can communicate that to a business guy, they understand. They say, oh, yeah, you're right. I never thought about that. You're totally right. Of course you need more time. If you don't communicate, to be honest, I can understand every business guy who says, why do you need so much time?
It's very a black box to many businesses, right?
Yes.
But maybe let's zoom in a bit on what you mentioned about building teams or having different people in your team, because in your career you've led data teams. Now in your current engagement, you're also building a team. You're hiring people for the team. Nobody is perfect, right? So indeed, you have technical geniuses who can build the craziest stuff for you, the most advanced platforms, and then but indeed you can barely put them in front of a business person because they'll totally collapse. And then you also have a bunch of smooth talkers, I would say. Well, that's too negative, but people who are very easy to talk to business, understand what they need, communicate progress to business, but they not very often that those are also the technical geniuses, right? So when you assemble an ideal data team for an organization, what kind of profiles are you looking for? And how do you deal with inevitable weaknesses in your team members?
What I like, first of all, is having a mixture. So as I said, if you know already, hey, I have a team of 4 engineers already and they are all very communicative, then it's not a problem if I hire somebody who is more a quiet guy. If I have to look on the other way around, just quiet guys, maybe I need somebody who can also communicate. That's my point of view, make it diverse, to be honest, because it's also a mixture of having experienced guys and beginners. And that's also something what I really recommend everyone. You can learn from everyone, everywhere. I have learned from the CEO until to the intern, because all of them have different experience. And just let us be honest, how many tools and technologies exist outside? Most of them we don't even know. So, meaning there's always somebody who can tell you, I have done that and that, and maybe that is exactly what I need. So that means also, I'm not a friend of, this, sometimes we need somebody with 10 plus years experience in that and that. Yeah, but that doesn't mean that he is very good at that point. So if he was more managing and not going deep into it, it really depends. So that's what I would say also, making a mixture. So bring the senior guys there to listen to the more junior guys and lead them, but also the other way around. So as a junior, try to learn from experienced guys, because even nowadays, if you say, for example, I start now from scratch as our topic, and what do I want with some guy who has 30 years of experience in Linux, for example? I tell you, the servers nowadays are still in Linux, even if they call cloud and serverless. There is a server beneath. So
could be Windows. Let's not go there.
Let's not go there. But could be. It's true. But 90%, I think.
It's. I mean, any decent system is built on Linux.
Exactly.
No, but it's interesting because we actually had a discussion earlier that exactly as you say, 10 years of experience doesn't mean 10 years of different experiences. It can be that person has done 10 years the same thing over and over again. And then if I can choose, I'd much rather have a person with 1 year of experience, but very eager to learn and hungry. And because I know that person will struggle in the first 6 months with all the new things coming at him or her. But after 6 months, their learning curve will be much steeper than a guy with 10 years of experience who's been doing the same thing over and over again. It's like, no, I know my one trick and I want to keep on doing my one trick. So for me, I look more to they need to have a good basic skill of engineering, or not basic, they need to be good engineers. But indeed, I don't care if you're like, do you have 4 years of experience in DBT or 7 years in Spark or 2 years in, I don't care. I mean, you need to have a good engineering basis, and then you need to have the ability to learn fast. Those two things I care way more about than how many years of experience in technologies you have, right?
Yes, it's also, I can just agree. I mean, look just in your own company. Look at the background of the people. Of course, many people have studied, but even there, we have people who never visit university. And why not? It's not a problem. No. But even for all these guys who studied, they have a background in, like myself, in economics. You have others in engineering. You have mathematics, physics. So you have a variety of things. But at the end, they do all the same. So, and that's my thing is you can learn a lot, and especially in technology. I mean, there's a reason why we just open the newspaper. Sometimes you read the 12 years guy, 13 years old, hacked that and that system, and you ask yourself, how is that possible? Because there are tools outside, and you can learn quickly, and you can learn from existing stuff, so you don't have to reinvent the wheel every time. There's already something there, and that's what we are often also do. Before we reinvent something, we just have a look, okay, is there maybe something outside which could solve our problem?
Yeah, no, exactly. And if you look at Dataminded, some of our best engineers don't have a university degree. On the other hand, I do feel that having a good, let's say in Belgium, we call them civil engineering university degrees, it's a good filter. That means that if you were able to get that degree, you're probably not stupid. It's very hard to be stupid and get that degree. So the likelihood of success in hiring and in working together with us is much higher if you already have that university degree. But that's just, that's just a statistic. There's plenty of examples that show that without a degree, you can be as successful or even more.
Yes, of course you can. And one point which I also wanted to add here, when you think about I hire a team, I make a team, don't look just only for experience and what they do. Also look at the guy or the girl itself to think, does he or she fits into my team? Because you can have a great team if you hire somebody who is just not very polite and somebody nobody like, you can destroy an entire team. So that's also important. You don't want to be best friends, but you should be able to work good together to make open discussions.
It's called the zero asshole rule. I have an experience that from a previous company where one of the most brilliant engineers I've ever met, let's name him John. It was not John, but John was 10 times better than I was, or many of my peers. He could do in a day what would take me a week. There's no discussion about the skills and the productivity of that individual. At the same time, he could demotivate the entire team around him by insulting them, by throwing away their code, by being just an energy drain on the entire team. And I always said that if I ever have my own company, even if that John person would come to my company and say, I'm willing to work for you for free, I would still not do it. Because no matter how productive you are, you can never be as productive as killing the productivity of 10 other engineers, right? So, and that's something that companies don't often realize, but having a brilliant jerk is never a good thing. And it hurts to remove the brilliant jerk from your operations. We've seen it at a few clients as well. Like this genius engineer that runs the entire team, and they have a bunch of minions around him and they do whatever he says. And companies always think like, oh, no, but we cannot lose that guy. We cannot afford to lose that guy because if he's gone, the entire system collapses. Well, but he often is the one creating the system in the first place. He created this bubble for himself, so that everybody and everything is dependent on him. Very often that person also has all the usernames and passwords of all the systems. It's his personal account very often. And the only way to move forward from that is removing that person from the group. And then we'll see with the other people in the group. Some of them are good, some of them are not so good. We can train them, we can coach them, we can guide them. But start of building a team is removing that person.
Yeah, I totally agree again, because to be honest, if you realize your complete department or company even depends on one person, you have made a mistake already long before.
Yeah.
So, and that's why I also said often when I go into a new project at the client side, I said, where's the documentation? And when what we are doing is let us spend time on documentation. I know nobody likes writing documentation.
We all hate it.
Exactly. I hate it as well. But I know the value of it. And there's also a point, there's a difference between writing a documentation, writing a long documentation, or writing a good documentation.
Yeah.
Because that's also true. If you, nowadays often Confluence is used, for example, or Notion.
Mm-hmm.
If you then want to figure out about a certain tool or a certain pipeline, how was it built, and then you have to read a book before, you don't do that.
Nobody
Exactly.
does that. Yeah.
So meaning, I'm a friend, for example, if you say, hey, like actually what you can see in Wikipedia, for example, you have a very short abstract way, just saying the most critical points, and then you can extend if you want to need some certain in more detail. So documentation is very important.
Right. Coming back to our stack, so we've had infrastructure, we had storage options. Then you need to choose technologies, right? And one of the big trade-offs that companies need to make is, do I embrace open source, or do I choose as much as possible managed services or SaaS services? And I know it's not black and white, always go for open source or always go for managed services. But then again, if you're building a data architecture from scratch, how do you make the trade-off between open source versus managed, and what should companies look out for?
Here again, I'm a very, very big friend of open source.
Yeah,
absolutely. But you need, many people just think, yeah, of course, open source is fine because it's free and you can especially save a lot of money, and that is where you have your first mistake. Having open source is fine. The problem is, and that is when it comes to managed services, is often we as technicians, we say, yeah, why not? We do go for open source. Of course, we can do that. If you do want to focus on your business and you don't have the people, you don't want to host your own Airflow system because you just say, I have no clue how to maintain it and I don't have the people. So meaning for me, it's better to have a company, and if something fails, I can just give them a call and say, hey, fix my issue.
Yeah.
So with open source, there's nobody to call, meaning you must have the people. And that's where I would start with. What is your business? What do you want to achieve? Where's your biggest problem? And then, okay, and which people do you have? Tell me the people. What are the skills? Let me speak to him. And if they have done that, then decide, what do you need in addition? And that is where I would make the decision, okay, there's something like an open source, for example, you need just some additional analysts who work on the data. They are probably easier to find. But now think of, I need some guy who's actually must be able to scale a system, taking care about security, manage the people, all that things. And already finding such a guy is very, very difficult. And of course, it comes also with a price. Let us be honest, those people are not cheap. So, and that means then it's perhaps a good idea to think about, hey, perhaps it's better to give it to another company, to go for some managed services, to let them do the work.
Yeah, absolutely. I think another dimension in this debate, which is very difficult, is that when you start from scratch, or when companies start building new cloud data platforms or whatever, they usually assemble a rockstar team of engineers and scientists because everybody likes to build new data platforms, right? You and I, we all love to build, let's be honest, and we all love to build new platforms. We can run an Airflow service on Kubernetes, and we can run a Spark engine here, and we can run DuckDB there. And but it's a lot of fun, and let's be honest, right? And then let's also install our own self-hosted LLMs, because what's the fun in calling an external API, right? So the building part, the companies tend to build as much as possible, or at least the engineers in companies tend to build as much as possible. But then companies don't see that whenever 80% of the build is done and you start switching to a more run mode or operations mode, a lot of the very good engineers, they tend to leave the company and find other places where they can build new platforms, because nobody is a big word, but not a lot of engineers like to run what they've built, right? So how do you deal with that stage of a data platform where most of it has been built, but now you need to run it, right? And very often a lot of open source systems have been put together, and now you become responsible for the run of that. How do you deal with that?
Again, let's hope we have some documentation. That's really the truth, because as I said, even if you say, okay, they are all tools I have seen many times, I know the tools. Trust me, you have nowadays in all tools, you can configure so many things that you need to know what's happened beneath. Even, let's say, for example, you have Databricks environment, and you know exactly what you need to do, and suddenly it still throws an error. Why? Because you have set it on top of an Azure, and then you have built some resource groups in Azure, and then you have somebody has made different settings, and they influence your system. That is where you need to deal with. So meaning, first thing is, when you just come to it, to be honest, that's often bad luck. Unfortunately, it happens. And as consultants, actually, we know it better than many other people, because one day you get hired, often exactly for such situations to figure out. And that's what we do. But it can sometimes really hard. So meaning, again, starting from scratch, meaning really spend time on thinking. Meaning, let's make another example. You said about every engineer wants to develop Spark, and I totally agree. What I have seen many times is Kafka.
Yes.
We want to do streaming. If you say as Kris, hey guys, I have a project where streaming must be implemented, I guarantee you, everyone in the company will raise his hand. I want to do that.
Yes.
Streaming is cool. Streaming is fun. You can do a lot of technical things. The problem is with streaming, first of all, building it is more complex than using a batch. Just simply the truth. Second thing is maintaining, and that is a part many people underestimate. They just think the hard part is development. No, maintaining is the hard part, keeping it alive and in a good way. And then we could talk about costs. Streaming is more costly, especially when it must scale flexible than doing a batch. And that means, again, if you implement it, document it very well, and ask yourself before, what do you do with your data? I have seen companies who just said at the end, we need streaming, we want that. And then what do you do with the data? We built our daily reports. And then I just said, you build a daily report. Why do you then go for streaming? It makes no sense. You can stream your data, for example, some data lake, and then just ingest it once per day. There is no need to make really a live ingestion.
I want to one-up you here. I've seen even worse at a organization that says, we don't know what we're going to do yet with the data, but we do know that we want to capture all the data in its rawest form in real time. And then we'll figure out what to do with it later. It could be daily aggregations. It could be monthly reports. It could be a machine learning. We don't know yet. Right? And so, but you laugh, but that company spent a couple of millions building that system that collects all the data all the time in real time from all their systems. Of course, it took much longer than expected. The platform was a lot more unstable than they predicted. But also the worst part is even the data that came into their system successfully, they didn't have a clue what it meant, because they just they used a bunch of CDC, like change data capture, to capture live changes from operational systems. But then you probably have seen CDC streams, like from try to understand what's going on. It's like reverse engineering. It's like somebody has been shot and there's blood all over the place, and you need to figure out like what in the hell happened into this room. And as an engineer, you try to do as best as possible to reconstruct what the data would have meant, to build a report, but I can guarantee you that with the best intentions, you will still get it wrong. So even the best case scenario where you do need the data and you want to use it in a use case, reconstructing it from a CDC stream is very hard.
And that's, again, coming back to the point, building that team. I'm really a friend of having a diverse team where you can discuss openly, where you make discussions, where you can work, let's say, like a democracy. But what I want, actually, also in addition, I want some guy who is responsible, who takes ownership, who says, at the end, you have to document. It's fine that you're building. We decided, for example, yes, we go for streaming for a good reason. Then it's fine. But you document what you're doing.
Yeah.
You don't make this one guy who is then responsible for everything. No, sharing knowledge. That's important. And to be honest, it's important from my side, for all sides, because some people just think more from the engineering perspective. Yeah, I make myself not replaceable because I just here. Trust me, everyone can be replaced. And second point, do you really want to be the guy who is not replaceable? Think about you getting sick. Think about you want to go for holidays. It's not fun when you get every day in your holidays a call, hey, we have some problem. Can you help? Don't do that. So meaning share the knowledge. Educate your more junior guys. So that's what I would always do. But have somebody who is not there as a dictator who just said that. No, but somebody who is more like who oversees it. Somebody who just say, hey guys, we are on the correct way, but now we have to focus here a little bit more and there a little bit more to give the guidelines.
But then coming back to the open source versus managed discussion, I do agree with you that building is easy, running is hard. So let's look a bit more into managed services. But there you have another trade-off, of course. Well, there's actually two. One is the more I use managed services, the more I'm going to be locked into those solutions. And again, lock-in is not black and white. But yeah, if I build my entire system, let's say on Databricks, which is a great managed service, but then it's hard for me to move it out of Databricks later. And secondly, I know engineers are expensive. At the same time, those services can become very expensive as well. When we started Go to Cloud 10 years ago with companies, indeed, you ran a bunch of EC2 instances. You built an auto-scaling group, and that was relatively cheap. But modern data systems like a Snowflake or a Fabric or Databricks or Confluent from Kafka, they're super expensive, right? So how do you deal with, okay, we don't want to manage everything ourselves. I understand we want to have more managed services, makes the run easier. But then how do I deal with lock-in and cost?
That's a really good point, because now you touched actually the problem of the vendor lock-in effect. We have mainly three big cloud providers. AWS on top, afterwards Azure, which is more and more coming close to AWS, and then you have Google, the GCP cloud. You
would rank them like that?
I would actually not. I would do that. I just look at the market shares.
Okay, got it. It's not that you think Amazon is the best, but you just think Amazon is you not think that's true. Amazon is the biggest cloud provider.
Exactly, and it just, Amazon was just the first guys who did that. So of course, then you have Azure, Microsoft just pushed a lot of money in it, and they have one advantage. The whole world is using Windows. The whole world knows Office and later Office 365. So it was just for them easier to convince people, hey, you're already using our software. Why don't you go also for Azure? It makes sense. So, and then came Google afterwards. Those are the big three. The thing is, if you decide for one, or even if you decide for a multiple cloud, which is very not easy to maintain and also costly, the problem is, and we all know that also from other softwares like SAP or Oracle in former days or SaaS, the problem is if they increase the price, you cannot really do anything against it because you depend on a certain system. And there's a reason you can always say, hey, let's go do some migration. Every engineer, if you say, hey, I have a project for migration, nobody's sitting anymore on the table. Nobody likes migration because it's a lot of work. It causes many problems all the time. So that's the point where I said, and which is actually our topic, what can we do? I mean, from a cost perspective, we have seen that in the last couple of years that the big three increased their prices heavily. And that brings me again to the point. See, what's it provided, or what they said in the first place, cloud is cheaper.
Yeah.
Nowadays, I would say it's a lie. We have seen invoices tremendous, extremely high. And that is why I said, think about what you need. Think about not only on-prem. It's not really often needed that you go back to on-prem systems and hire your own local engineer teams. I don't want to say that. But think about, hey, there are other providers, especially, and that is actually also, again, our topic. Nowadays, we not only have a price problem that you maybe should think about what else do we have outside of these three big providers. We have also now a new president in the White House in the United States.
Yeah.
And let us be honest, if you think that doesn't affect us, we are wrong.
Yeah.
We are so wrong. We see it already. And when you look at the dependencies, I mean, now we have a lot of discussion about, of course, the military sector. But if you go to the IT sector, wow, many, many things. We completely look at, if you start not be talking about cloud to make it maybe a little bit more obvious for non-technical people, just have a look at the computer market. You have Windows with, I don't know how many market shares, 70%, 80%. Then you have Mac. It's also an American company.
Yeah.
So if you go for the mobile phones, again, you have Apple, you have Android, which is, okay, it is some Linux system, but at the end, it's again America. So meaning, in the past, we trust the United States a lot, and I would still say we trust them a lot. But are we sure that is the correct way? Because I would say we live now in historic times, and the next years will be very interesting because due to the election, we see the first election of Trump was not an accident. It happens again. So, and we see, if you look at Europe, at all the extreme right parties who now pops up with, again, that's the topic of fake news, with just telling lies. We must be very careful about those systems and maybe think about, should maybe go for another provider.
So you're saying there is, without diving too much into politics, but there is a bigger trend in the world which is not necessarily positive, and people like Trump are a symptom of the trend. But even if Trump goes away, the trend might still be there. So it makes sense for EU companies to think a bit more about the geopolitical considerations behind building data platforms, right? But then let's start with a very obvious one. If you say, we don't want to be dependent on the US, but I say, well, it doesn't matter. My data is hosted here in Frankfurt or in the Ireland region of AWS, so I'm safe, right? So is that not just good enough to select the EU data center of one of the big cloud providers?
Yeah, and that's again the point. I mean, let us be honest, even before Trump, we had all the discussions about, especially GDPR.
Yeah.
So is it even safe to store it there? So in the first place, okay, all these big centers were in the United States. Then you say, okay, it's not safe. Now you say, yes, it's safe in Frankfurt or Ireland, or European Union, we are safe. Yeah, I would say on the one side, it's not completely wrong because, your data is physically in Germany or Ireland. So, however, the provider is still a United States company. And they said in the past many times, your data is safe. Even if the United States government said, we must deliver them data, we don't do that. Personally, you trust just on that one that they say we don't do that. But what happens if if some laws say, no, you must deliver?
Yeah.
Then you have actually just one choice. It's saying, okay, I'm be super paranoid. And I don't want to tell now conspiracy theories, but I just encrypt my complete data. You can do that, but it's again, effort. You need to do that. It's costly.
Yeah.
And then, we have the technology progress is very fast. And that means just because it is safe today doesn't mean it is safe tomorrow. That you cannot unencrypt it tomorrow. So, and
Yeah, and I think there's another case with encryption. We actually worked with a government agency that uses AWS, but they had this reasoning indeed about GDPR and sensitive EU data that they didn't want to put on the AWS cloud, even though it was an EU data center. They didn't want to put it on AWS. So what they did, what we did together with them, is build a system of encryption. Well, it's not super hard. It's just putting a flag on S3 and your data is encrypted. But we put it a bit more advanced, as in the encryption keys were stored on a hardware device somewhere outside of the AWS cloud in Frankfurt somewhere. It's HMS, like a hardware managed security, whatever. So all the data is encrypted at rest on the AWS cloud. And even if tomorrow the FBI says, I want that data, they can get a copy from S3 because Amazon is legally required to hand it over, but it's encrypted and the keys are not under their control. So you think like, yeah, happy days, this is secure. But then, of course, your system is not only living at rest, you get use from your system when you run it, right? So when you query the data, when you process the data, when you train, and then you need to somehow decrypt the data. Sooner or later, you need to decrypt the data, right?
Exactly.
and then so in those, it's never a 100% fail-safe system, because when your data is being used, it lives unencrypted somewhere. It is being decrypted, and of course it's secure through multiple layers of security. But in the theoretical case of the FBI gains access to your systems and AWS lets them do it, it's very hard to protect yourself if you're on the AWS cloud, regardless of all the measures that you take. So let's say I am a very paranoid EU company. There's no way I trust AWS. Even if I store my encryption key somewhere else, I want to be completely decoupled from the big three. What are some alternatives we have in Europe? How can I build a data architecture from scratch without the big three clouds?
Yeah, that's a good point. So first, let me start with the security part. There is for sure, and you know that, I know that, you never really will reach 100% secure system, because that's why I often said you have a trade-off between security and doing something with the data with the flexibility to work with data. So meaning, if you wanted to describe it on the top, what is the most secure system? A system nobody has access to.
Yeah.
So simple solution, but what we will do with that one? So meaning, okay, let us go back. We have multiple providers in the European Union who could overtake in some parts, and that's really my point. Some parts. If you just would say now to me, I want to replace my AWS services and I use all of them with some European provider, sorry, probably not possible. I'm also don't know every provider in the European Union, but probably there is no one who can do that.
Well, on the lowest level, you probably run on infrastructure provided by Dell or HP and chips provided by Intel or AMD. So on the very lowest hardware level, there is always. Indeed, I agree. You can never decouple 100% from US technology. That's a lie. That's a fantasy. There will always be some US components in your stack, right? But then, what are some possibilities that you know of that makes us less reliant on those US technologies?
That's what I said. Think about, again, in the first place, I'm really into that topic. Think before you start. What do you need? So you have often that case that you say, of course, it's obvious. I need storage. I need maybe some virtual servers. I need a database. Pretty obvious.
Yeah.
But that is something actually every or most provider in Europe offer as well. No problem. And then think about, okay, what do I need in addition? What do I need maybe for orchestration? What do I maybe need for logging, for monitoring? And then you go more into the details and then really think about that. And then have a look what's outside. You have provider like in Germany, I know, for example, Ionos. We have now Stack IT, which is from Lidl, from the grocery discounter.
And so what is it? What is Stack IT exactly?
That's actually what Lidl is going to do. You would now think first, Lidl and computer technologies, how does that match? let us be honest. I mean, have a look at Amazon and AWS. That's how the story started about complete cloud technologies.
Yes.
So, and they have now I think it's in Heidelberg in Germany, where they have built a huge campus. I don't know how many people, but a lot.
Cool.
And we're just building new technologies. And they also said, and right now they do that they offer their services to the public market. So meaning there are alternatives. Would need to test it. I just had to look at the surface, so also not much. I cannot now tell you the exact differences, but the main topics are there, and there are also other things. However, as I said, you cannot replace it by 100%. And then there's one point which, from my point of view, we often underestimate in Europe, maybe especially in Germany, the level of service. The Americans are great when it comes to services. So meaning you have a problem, you give a call, you write an email, a ticket, whatever, and you get an answer. And you get a friendly answer, and you get often an answer which solves the problem, or at least it brings you closer to the problem. In Germany, I often see it actually like, we don't react because we have service times, or we don't do that, and I don't know. So it's also about, how do you get treated? If you pay for services, it's also how do you get treated? I don't want to say, hey, everyone acts like that, but see, it's different if somebody says to you, I will take care and I will do everything and I will call you as soon as I have a solution, or it's just somebody said, you are number 6,000 in the line, and
no, absolutely. I think in general, the American companies have a customer first mindset. Although I have to nuance that a bit with the larger you go, the less that is true. What do I mean by that? Let's say the big three cloud providers. If you are a large consumer yourself, you probably get a dedicated solution architect or something, and he's there, he's going to hold your hand, he's going to help you, whatever. But if you're slightly smaller, I don't know if you've ever submitted support tickets to Microsoft for something in Azure. Yeah. That is like the most excruciating torture known to man. And that is horrible how you get treated. You get passed around from support rep to support rep to support rep, usually on the other side of the world. They don't understand your problem. You have to explain it 10 times over and over again. And in the end, what they do is send you to a knowledge base.
Yes.
Which doesn't have the answer. So it is true that in general, American companies are way more customer centric than European companies, but it's not that black and white either, right? So
no, it's not. It's not that black and white. And to be honest, maybe it's just human nature. Have a look. If you say, for example, even as a large cloud provider like AWS, and you would say, I have so many customers, I don't care about a certain customer. Then you have suddenly a company like Netflix. I'm not sure about the numbers, but I have in mind that they spend around $50 million every month for their services.
So I would even, I don't know the number either, but I would even guess it's higher. But anyway, yeah.
But whatever the number is, it's huge. So if you have a customer where you think about, okay, he probably, if you calculate over a year, we're talking at least of $500 million. Then you will treat your customer very well, and you will probably treat it better. Like if I come with my personal EC2 instance problem where I spend $5 per month. So of course, that's just
normal.
Exactly. That's just human nature. And to be honest, I don't want to blame anyone for them because that's just normal.
But I want to come back to something that you said earlier that I agree we cannot replace state-of-the-art US cloud technology. So is there a European Snowflake? Is there a European Databricks? Is there a European Confluent? No, there's not, right?
Yeah.
Okay. Is there?
That's my point. Now we left a little bit the area of just the cloud providers who actually offers everything from infrastructure and so on. Now we go more to environments like Snowflake, Databricks. Let's take those one. And again, first point, you will find many articles about Snowflake is superior to Databricks and vice versa.
Yeah.
It always depends of what does the people have for experience and what are their needs. Let us be honest. They offer all of them offers many, many functions. And probably you don't all need all of them. maybe you need half of them. So if even. So, and that brings again the question, should I really use that service, which are great, by the way? I mean, Snowflake, Databricks, I really like them. But there are alternatives. However, they come with a price. Maybe the service is not as expected. Maybe the user management is not what you would like. Maybe it doesn't scale as you like. Maybe even, I mean, for example, there's some tool, Data Band. To be honest, I also didn't test it. I want to test it soon. You can host it by yourself. But then again, hosting by yourself means you need the server. You can, of course, you can go to some, I don't know, some Hetzner server and buy some cloud, servers there.
Yeah.
But then again, the question, you need somebody who set it up. And again, set it up. Yeah, I hire some consultants who does that. Yeah, but the problem is not solved. You need somebody who maintains it. And then is again the question, we have costs and is it worth the value?
Yeah.
So there are alternatives for sure, but I would say nowadays it requires more effort to investigate what are actually the difference and especially to figure out what are the things which are not great. So what I do actually very often is when I investigate for a new tool, I start with a Google search, just type in the tool and then disadvantages. That's the first thing I do to see what is, but that is just the truth. I mean, the problem is if you have some big providers like Snowflake, Databricks, you will find easily what is not working so well. But for smaller things, sometimes you just figure out there's a documentation. And all what they say, if you look for advantages and disadvantages, is just what they write on their own homepage.
Yeah, it works for everything, for everyone. Yeah.
Exactly. And that's where I'm often said, be a little bit careful. Another example, I don't want to say that some of the companies lie. That's not the truth, but what do they compare? So, for example, I had yesterday a discussion with a colleague about Spark versus some other tool for loading data. What about the thing? And they said the new tool is better. It's for free. It's way faster and so on. And I just asked, okay, what did they test and how did they test? Ask yourself that one, because I can tell you, if you load, for example, 100 megabytes with Spark, and then you compare it to even some default tools like Pandas in Python, Pandas will be quicker. Yes, it will. But that is not the purpose of Spark, to load 100 megabyte. So, and that's also what I meant. Have a look and always ask yourself, what are my needs?
I think that is very true, and especially for the more advanced use cases, you'll get stuck with what you can get in Europe, or you need to build a lot of it yourself. Then again, if you're really honest and you look at most data organizations of large companies, 80% of their workloads is relatively simple storage of relatively small data. Talking about a few terabytes max. It's relatively simple ETL pipelines that can run on Python, Spark, or dbt, or whatever. And it's relatively simple reporting. I know in conferences we all like to talk about super advanced MLOps systems we built and about LLMs and stuff. But I think 80% of workloads that are important for companies in day-to-day critical operations is simple loading, transformation, and aggregation of relatively small data. And there I do believe that a relatively simple solution brings you just as far as a Databricks or a Snowflake or something. I would even say further. Wow.
That's what you see outside. So today in Germany is this official alarm testing, at least here in North Rhine-Westphalia. That was a test alarm.
Really?
Yes, exactly.
Okay, all right. No, but so
you hear it outside.
And you got it on your phone and you hear it outside.
Yeah, that's now outside from every mobile phone.
Gets an alarm now.
Yes, exactly.
For what?
For just a testing to see if it works.
Okay. It's very German. No, so coming back to what I said, so most companies today, 80% of their workloads is fairly simple. It's aggregating relatively small data, ingesting relatively small data, doing something you can run with any kind of dbt or Python or Spark jobs, right? So the question I have is, do you think we need US services to do these kinds of workloads, or do we have other systems that are just as easy to manage and just as easy to run?
We have definitely systems which are easy to run and easy to set up. To be honest, it's often also the case people are a little bit afraid of touching something. I miss a little bit the spirit of just try it out.
Yeah.
Just test it. So for example, I mean, let's take as a database. The default database is Postgres, one of the well-known databases in that world.
Decades old,
but even under construction and even supported today and maintained and developed even further. Great tool. And many other things, even if you go for Azure or AWS, they offer that one as well.
Yeah.
Because it's a very good tool. And then some people just said, setting up my own database. And when I just tell you, hey, we have technologies, and actually nowadays it's so easy. Just go, for example, install Docker. How can I do that? Just read the documentation. It's actually pretty simple. Not really more than putting a download button.
Yeah.
It's installed. And then pull the image of that, which is also one command. And then it is usable, at least for testing it out. I mean, of course, there's a difference between just testing and having it running in production.
Yeah.
But there are tools outside which you can use for that, of course.
All right. So you talked a bit about Stack IT from Little. Are there other real-world examples that you know of EU technologies that are good in a data stack?
Yes, for example, we have different providers. I mean, we have it from France, from Germany, from Finland. As I said, all of them have their own advantages and disadvantages. In addition, you must ask yourself, and then again, investigation, what are they doing and are they really independent? So we have a very famous example in Germany where our former and actually current chancellor just advertise to use the SAP cloud, which is, okay, you can do that, but beneath it was still Azure.
So, really?
Yes, exactly. And then is the point, I mean, again, I'm not a lawyer. I don't know how it is completely. Is it now really independent, or because SAP has maybe the oversight? I have no clue. But again, just from my thinking, it doesn't sound correct. If we again then depend on a American company, yes. So what I would really say, make your homework before you start such a journey. Make your homework and spend rather a couple of days more on investigating and really think about your needs and what can solve your issues, than just going for, I mean, would say the advertising trap of, I mean, if you ask a Snowflake guy what is the best tool outside, it's Snowflake. If you do it for Databricks, it's Databricks. You will see it everywhere. Their own tool is always the best.
All right. Going back to a few things we said earlier in the conversation, let's go back to data modeling. Nowadays, we already discussed you have a data warehouse, a lakehouse, or data mesh. There's also some companies that say data modeling, I don't really care anymore. Storage is cheap, compute is cheap. I can scale infinitely in the cloud. So I just load all my data in one big table and everybody does whatever they want with it. How do you look at that?
Yeah, I mean, depend from your perspective, right? If I would be a shareholder of Amazon, sounds like good money, right? To be honest, and that's also what I would always think about. Don't just look at the numbers and think, that's not a problem. I mean, when I remember back, one teacher, I don't know who it was, but one teacher said to me, people are very bad in two things. That is probability theory and working with large numbers, to just look exponential functions. So how quickly can increase something. And we have here exactly that. When you look at prices, storage computing, it's so cheap. You just say, hey, this is nothing. We speak about 0, 0, 0, 0, 0, I don't know how many zeros before you pay actually. Yeah. But if you then look how many data you have, you suddenly ends up, as I said, the example with Netflix, with even millions per month, because you have so much data. So, think about that. And that is where I make my point regarding data modeling. I think even today, I mean, in former times, we did it a lot because storage was not cheap.
Mhm.
And we needed it carefully. Nowadays, yes, things have been changed and we are going away from this 3NF models that we say, okay, we want especially analytics and we want to analyze. So we need anyway some different models.
Mhm.
But I would still do that because having let's say you just say, okay, I go for one big table and I ingest everything in that one table. You can do that. You have the hardware. And even if you say, I don't care about the money, it is not be fun for the data engineers, to be honest.
Mhm.
It's just ingesting all the time, and sooner or later it can also lead to issues. Second thing, even with more hardware, it just simply needs more time.
Mhm.
And then think about the analysts, or even people who are not really analysts, who are even less, who just have a look maybe from time to time.
Yeah.
For them, it's really hard to say, for example, I have one customer and now here I have here different entries and what is now the correct one? How can I filter? They just don't have the knowledge. So I think data engineering doesn't end with the ingestion part and then done.
Mhm.
No, I still think it's really relevant to model that data carefully. And then we are again on the data mesh, best model it together with the business side because they have the knowledge. They know what to do with that data.
Yeah, exactly. No, I agree with that. I do think the times of centralized modeling are behind us. I don't believe anymore in one big data warehouse with one Kimball model or even data vaulting. I'm not a fan of. Just because there's this idea of there's one central place where we model all the data for the entire company. It looks good in paper. I've never ever seen it work in practice. I do believe in what you say. Modeling is still important. But we move it a bit to the domains. So each domain should think about how they model their data. And also, you used the word documentation a few times. It's just as important as the modeling. And I have an example of that from a manufacturer. There was this huge escalation at some point because the CEO of that manufacturing company looked at two dashboards, looked at the finance dashboard and looked at the supply chain dashboard. And the finance dashboard said, we have 80 pieces in stock of a certain item. And the supply chain dashboard said we had 100 pieces in stock. And the CEO was pissed, like, how could you, stupid data team, how can you be so wrong? It's either 80 or 100. Figure it out. And so they looked into what was wrong. And it turned out that they were both right. So what do I mean? The supply chain team, they looked at the actual physical count of items in their warehouse and they saw 100 items. But when you asked the finance team, they said, yeah, there are 100 items, but according to bookkeeping rules, we need to depreciate those items. And after 5 years or whatever, they are written off. So 20 of them were more than 5 years old. So we only have 80 items that have any accounting value for us. So we see 80 items. And you will never, ever, consolidate those two numbers. It's the same. We worked with a train company that couldn't agree on what a train was. We worked with an education company that couldn't agree on what a school was. A school is something different from inspection, than from building maintenance, and from teaching. And there's always different definitions. We worked with energy companies that couldn't agree on what a customer was. And that's all fine. Like coming back to this manufacturing company, you just need to, every domain needs to be very clear what they mean when they say we do an inventory count. What do we mean by that? And I think that is, so you need to model it so in an easy way that people can consume it, but also you need to document what you model, right?
And you might need to model it carefully. That's what I meant with good documentation and just long documentation. And that's what I also meant when I talked about how do you filter data. If you filter different, you get a different report.
Yeah.
And that's, it's very true. What I often see, for example, and I don't know how often I have spoke about that, but I see it again and again and again. Timestamps. The timestamp is very useful to know exactly, okay, what happened when.
Yeah.
The problem is, many people nowadays, of course we have a timestamp. When was it set? Especially in international companies who work over different countries and time zones. Yeah, we set a timestamp. Yeah, thank you. I don't know from which is it's coming from, and I don't know the time zone, and then I have problems. So that's also, for example, if you something like that. So when I create timestamps, I make sure I use always UTC, and I documented, hey, this one is UTC.
Yeah.
And actually every timestamp I use is UTC.
Should be.
Except I tell you this is not UTC, but then I document it.
Yeah.
That's very, very important. Another topic is when it comes to data modeling and also storage costs is what many people don't know is maybe the wrong word, but underestimate is, okay, how do you store data? Just in a simple example in S3, data is stored, data is available, but then you have maybe data which is just getting old. When you say, yeah, maybe I want to keep it, but then there's a solution for an archive where you say, okay, the data is not, if you really need them, it takes some hours before you get it back, but the storage is even cheaper. Yeah. And that is what I would also think of. So I had, for example, a project once where we were talking about invoices. Yeah. And they had a company was not a young one. So meaning they had invoices for decades. And I asked them, how far should I go back? Yeah, everything. And I just said, okay, I can do that, no problem. But my question is really, what do you want with an invoice which is 20 years old, 25 years old? What do you want with that? There's no value in it from my point of view. And of course, then we again on the discussion, engineer versus business side. So I ask the business side, which is something, to be honest, you should do very often when you come to something in as an engineer. Ask questions. Ask as many questions as you can. And that was my question. What do you want to do with that? So I didn't stop at, yes, ingest everything. I just asked why. Tell me the reason for that. Yeah, it turns out that they later agreed on, actually just load the last 5 years. That's actually enough. We don't need it before.
Yeah. I actually know of very few use cases that need more than 1 or 2 years of historical data. But there definitely are use cases, right? But most use cases don't. Actually, that's one of the interview questions at Dataminded that we used to do. I can't tell it because we don't do it anymore. We used to, when engineers came and interview with us, we gave them a link to historical flight data from the US. There is a database somewhere of the last 15 years or something, arrivals and delays and which company, which airport and whatnot. And then we asked them to analyze that. And I am an airport executive and you need to report to me the delays and what can we do about it. And one of the easy tricks is ignore the first 14 years of data and look at the last 2 years. Because I don't care how my airport performed 15 years ago. I mean, as an executive, I want to know what was the delay in the last year and do I see a trend maybe of 1 to maybe 3 years, whatever, but and which airports am I competing with, so to speak, and what can I do? Which airlines are often delayed, which kind of airplanes are often delayed. But I don't need 15 years worth of data. And the funny thing is that 1 or 2 years worth of that data you can easily process on your laptop. You don't need to build any complex system. But 15 years of that data, well, then you need to build out Spark clusters and I don't know what big data systems that you need to process. And that's a good test actually for the engineer that comes in. It's like, well, I focused on the last 1 or 2 years. I like that. That's a plus in my book.
Yeah, and it's actually true. And that's, ask yourself again, what are my needs? Because I have it seen in both ways. That you say, I'm just interested, like in your airport example, I don't care how my airport looks 15 years ago because it was a complete different airport. So that's fine. You focus on the most recent data. Other companies, in parts, make the issue a little bit the other way because they said, I'm for example the customer relationship team. I'm only interested in the current data of a customer. I only want to know where does he live right now and all that things. But then you must say, but think about maybe another team, or you must rebuild a report. So it makes sense to track the changes over time. But then again, I totally agree. It makes sense to track it over a couple of years, but not over, 20 years.
No.
And maybe you even know, hey, that is not even our customer anymore.
There is this other hype coming up now also within data where they say, you don't need all this data modeling anymore. You don't need data governance because soon we'll just throw all the data to an LLM and the LLM will answer all the questions, right? So why do I need to spend time structuring the data if an LLM can deal with unstructured data?
Let me answer that question with another question.
Yeah.
If I would be a financial auditor to your company and ask you, I need all your financial data now because we make some tax checks.
Mhm.
And would you just go now to say, okay, my LLM now aggregate all my data which I have and give it to that guy to make some tax proof?
Yeah.
You do that?
Probably not, right?
Yeah. The thing is when we talk about AI is not just an LLM. So there are many more things outside, but it's of course nowadays the most famous one because they're very powerful. Nevertheless, all of us has experience in seeing sometimes strange answers, which are simply wrong. You see it in the first place. The problem is often you don't realize that one might be a wrong answer. And if you are a coder, there you have often the chance to test it out to see if it works or not. But again, you have some problems. First of all, they have a certain time spot until they were trained. So meaning if you want to go for a newer thing, and we all know how quick technology evolves, then maybe it's not included. So maybe you use it in the old way. Another point was I just tested it when it started with some SQL script. I just said, hey, I have some Python code, and that Python code should just generate a process to ingest data into a data warehouse by using some SQL code.
Okay.
What does it do? It was very good. It gave me an answer within seconds, and it was working totally fine. What was the problem? When I analyzed that code, it opens every door for SQL injection. So, and that's what I meant. If you don't have now the experienced guy who see that and not just copy paste, be careful of that one. And in the other examples I just aggregate the data. Do you really trust such a system nowadays? I don't speak about maybe in a couple of years, but nowadays, that they aggregate correctly, that they don't miss data, that they don't add data, which is just, we have seen that they just add data, which is completely wrong.
They hallucinate.
Exactly. So I wouldn't trust them nowadays. Maybe it will be better in the future, but again, then I would think it also depends on how do you ask the LLM. We have all seen that you make several tries before you get that what you want.
Yeah.
And that's not easy.
At the same time, I completely agree with you. Like trusting LLMs blindly is stupid from a business side, also from a technical side. So all those ideas of we don't need data governance anymore, we don't need data modeling because an LLM will format it for you. That's nonsense. If a human can't understand it, what do you think an LLM would be able to make sense out of it, right? Then at the same time, I do believe that if you use an LLM as a tool, it accelerates you, both as an engineer, as a company, you can't put it on cruise control yet and just do whatever you want, and I won't look at it. But I do believe, so there's this quote, LLMs won't replace engineers, but engineers with using AI or using LLMs will replace engineers who don't take advantage of it. Do you agree with that?
Yes. Yes, simply I agree. It's a simple reason. Do I use tools like ChatGPT? Yeah, of course I do. I don't use it for the very most complex things, but often it's just like, we all know that you have worked for several years with a certain tool, but some commands you still have to Google again and again and again.
Yeah.
You just simply forgot them. I have, for example, often the case I need for, let's say, a Docker image. I just say, okay, hey, I need a Postgres Docker image just quickly with some user and so on. And I just say, hey, give it to the LLM, just create it.
Yeah.
Because for me, I see what it is. And for testing purpose, I don't even care about security or anything. I just need to run to check, and then I can adjust it afterwards. So meaning here I spend already, I save already a lot of time.
Absolutely.
So it has its value for sure. But again, you need to know what can it do and what can it not do. And second thing is, especially when you work for companies, be very, very careful what you put in. We all know there was a case, I think 1 or 2 years ago, where the Korean company,
Samsung.
yeah, exactly, where they put all their production code into it. Yeah, that wasn't a good idea. But that's what I meant. I mean, always think about the limitations and what do you use. It's also the question again, which model do you use? Do you use some open source or not? And we also must think about not only the training, costs a lot of computing time, but also the answers. So meaning most of the things are running on some external servers somewhere in the cloud.
Yeah.
So meaning if you want to go now, for example, hey, I have some very sensitive business documentation, perhaps not the best way to put it in something like that. But there are also coming more and more solutions, even where you think, even systems where you say, I can put my own LLM in my own office just for me.
Yeah.
So there are possibilities.
I think, especially for large companies, that becomes more and more feasible that the LLM runs within your boundaries. And that can still be that you run it on a cloud service, but it's a cloud service that you run and maintain. Or it can be an on-prem system. I think more and more that will be possible. I think that's part of the answer, because even with best intentions, if you use a service like OpenAI, you can never guarantee that nobody will put your production code in that system, right? So you need to put some boundaries in place.
Yeah, and I would also add something. I mean, we talk a lot about using LLM as we call it AI, and we use it for code, we use it for some summaries and so on. To be honest, AI is more. And if we combine it, there's where I actually see really, really big chances for the future for actually all people. I mean, just think about it, like using deep learning to analyze images from X-rays, where they can see, for example, cancer, where you can, which the doctor didn't see before. They can see it. And then you can, for example, combine it with some chatbot where just say, hey, please explain that diagnosis to me, where I have no clue to understand, to explain it in simple words. And that is where I think there, when we combine such things, there you can make really a value for humanity, actually.
Yeah, absolutely. There are plenty of cases, you say medical imaging, but also just document processing, things that required the purposefully trained machine learning model in the past. Now off-the-shelf algorithms outperform them, and that means that you can basically just handle a lot more cases with AI, right? So where it used to be like the investment would be $1 million to have a team to build that for you, now you just take it off the shelf basically, and it opens a lot more opportunities, right?
Yeah, and I think it will change a lot. I mean, we touched coding, we touched now medical sectors, but even the complete area of consumers. So I'm pretty sure that we will see it within the next years, that you as Kris in your private time come home, that said, okay, I want now to watch a movie. Should be around an hour, should be some action movie because you like it. I don't know. Let's some add on it. It should play in Belgium, something like that. Yeah. And then you get the AI will create your own movie just for you.
Oh, yeah.
I think that will come in the future. I'm pretty sure. And I mean,
it's a cool thought.
To be honest, I mean, of course, now then you have the disadvantage of people who work in that area. We just say, hey, they are taking over our jobs.
Yes.
And to be honest, for me, it's actually the same like when we talk about engineers who don't use it. Yes, they will be overtaken. So meaning, I think there is just a way to adapt such systems to use it in addition.
So you need to embrace it.
Yes.
All right. I think that brings us more or less to the end of the episode. To close off, as a final question, what is the biggest lesson you've learned in data?
First of all, data is never be the same. And what I really learned, you can solve many, many issues with technology. And you can actually solve for every technology problem, there's another tool or some workaround or something which can change it. The biggest issue, from my point of view, are still humans, meaning a culture in your company. If you have a culture where people say, no, I don't want that. I want still my everything on paper and I would just want to do how I have done it for 30 years, That's the biggest problem. And that is actually the most hardest way to change a culture. So meaning from a company who is a product to coming also really data-driven. That's what I meant in the beginning with you should make your decision, from my point of view, based on data and not gut feelings. And that's really the point. So changing culture is actually what I see mostly as the biggest challenge.
And I agree. But then how do you change the culture? What can you do with companies or departments or individuals that are very reluctant to change and very reluctant to embrace a more data-centric mindset?
By convincing them part by part. So for example, when I just say, hey, you have done now your report, like in many companies using Excel, probably the most used tool everywhere. So, and I would just say, they spend now the whole day to build that report. And when I can just say, hey, look, we have now adjusted it. I have worked together with you that I know exactly what you need, what you want. And now I show you, and that's the real thing, I show you the solution. And all what you have to do is, for example, open your browser in a dashboard and you see whatever you want. You can even play around. But that's also the point. I mean, let us be honest. We as engineers, we don't like dashboards. It's not the way what we're doing. However, I cannot expect from somebody, if I would say to that single person, hey, you just have to go to the database and run that code, and then you get what you want. Yeah, they would just, I should run some code. And no
it's not
way.
going to happen.
So exactly, that's not going to happen. And that means make things simple. I always compare it actually to Apple. When they first introduced the iPhone, there was already smartphones outside.
Plenty,
exactly. But why was it suddenly such a game changer? Because it was so simple that every child understood how it works, what I can do with that.
Yeah.
And that is what I meant often. And that is actually where I also see many engineering struggling, not only building good systems, but building systems which are simple to use at the end for the end user. And then we are again on documentation. It's far easier if you offer a dashboard and there's a like column names or table names.
Yeah.
You don't go for table name test and then the columns A, B, C, D. No, you give meaningful names that at the best the people directly understand, okay, what I'm looking at. Or I have a documentation in addition for that. So meaning build systems simple, easy to use, easy to explain. Then you can convince people, hey, it really has a progress. To be honest, the best thing I would always say, if you can show somebody you can do their work, which they have usually needs a day or two, in just a couple of minutes, then you have them.
Yeah. Well, at first, sometimes they don't believe you. It's like, that's not possible that you've done it.
Exactly.
But then once you verify that, oh no, exactly. Yeah. Then you bring change, right?
Exactly. And that's, but for that, you need also some trust. I mean, we all know the stories about, probably nowadays they're all retired, but 20 years ago, where you had really people with a calculator next to their Excel sheet to really calculate with the calculator, is that one really the right number Excel is showing me? So from computer perspective, we say, okay, of course it's the same number. Why shouldn't it not? But they really use the calculator because I don't trust that computer stuff. So, and nowadays, I mean, 20 years ago or 30 years ago, technology was not for everyone. But nowadays, I mean, look around, everyone is using technology. So I think convincing the people is actually a little bit easier. Nowadays, they understand.
All right, cool. Torsten, thank you very much for joining me in our very first episode of the Data Leaders Playbook. Wish you all the best.
Thank you for being here, and it was nice. Thanks.
Thanks.